Good morning, Year 4. Our maths lesson today, continuing with decimals, we're looking at hundredths on a place value grid. So, our anchor task, we're looking at our vocabulary. Can you match up the vocab with the correct meaning? So pause the video and have a go now. Okay then, so a hundredth is one of 100 equal parts. A tenth is one of 10 equal parts. A fraction is a part of a whole. A decimal is a number expressed in scales of tens, and to partition is to divide into parts or share. Well done if you got those correct. Okay, so having a look at the flip chart page in front of you, we are now looking at counters in our place value grid and turning these into decimal numbers. So write the decimal represented in each place value grid. So in my first grid then, there is how many ones? So I have 1. How many tenths have I got? 1, 2, 3. So I have 3 tenths. And I have how many hundredths? I have 0 hundredths. So my decimal represented is 1 whole, because I've got 1, 1. My decimal point, 3 in my tenths column, and I have nothing in my hundredths column. So I could either leave it blank or I could put my 0 for my placeholder. Let's try again then. Let's have a little look. How many ones have I got? I've got 3. Tenths, I have 0, and hundredths, I have 1, 2, 3, 4. So again, my decimal represented 3 ones, decimal point, 0 tenths, 4 hundredths, 3.04. Okay, so these decimals in a place value grid, use the sentence stems to describe each number. So now we've had a go together, so now I want you to do this independently. So break up each of these numbers, okay? In 0.34, how many ones have we got? How many tenths have we got? How many hundredths have we got? Okay, so pause the video and have a go in your books. Okay then, so for 0.34, we have 0 ones, 3 tenths and 4 hundredths. 2.15, we have 2 ones, 1 tenth and 5 hundredths. 0.03, we have no ones or tenths, but we have 3 hundredths. And 1.01, we have 1 1, 0 tenths and 1 hundredths. Well done if you got those correct. So we're really showing our understanding of decimals and fractions and putting those decimals into a place value grid. So let's have a look at these two numbers. Compare these decimals, which is bigger. So we've got 2.30 and 2.04. So let's use these place value grids to help us. So we have 2 ones, 3 tenths, and 0 hundredths in 2.30. And in this number here, we have 2 ones, 0 tenths, and 4 hundredths. So now we can see it using our place value grid, we can more clearly see which one is bigger. And remembering when we compare numbers, we are using our crocodiles, our greater than or less than signs, or our equal sign. So let's compare these numbers. Well, they've both, starting with our ones column, they've both got 2 ones. So at the moment we can't compare them, they are the same. Let's move into our tenths column. So our tenths is our next biggest column we're looking at today. So it's the next important. So we've got 3 tenths in this number and 0 tenths in this number. So this one must be the bigger number because it has 3 tenths and this one doesn't have any. Okay, so if we go into our hundredths as well, you can see that the number to our right has got 4 hundredths and this one's got none. But that doesn't matter because tenths are bigger than hundredths. You would rather have 3/10 of a piece of cake rather than 4 hundredths of a piece of cake. Okay, so the 2.30 is bigger. So we would use this crocodile to show that 2.30 is bigger. Okay, then your bronze questions today are going to look something like this. Write the decimal that is represented. So quite simply, we are turning these counters into numbers. So we have 1, 1, remembering our decimal point. Then we have 2/10 and 1/100. So the number represented is 1.21. And now we're doing it the opposite way. Represent the numbers using counters. So we have 1, 1, we have 0/10, and we have 1, 2, 3, 4 hundredths. So we would represent it using counters like this. So your bronze questions then, you are either writing the decimal represented or drawing a representation of the number using counters. So pause the video and start bronze if that's where your starting point is. Otherwise, let's move on to silver. So for silver, we're looking at part-whole model, okay? So we have these numbers. We have 0.24 and we want to partition this number into tenths and hundredths. So how many tenths do we have? How many hundredths do we have? So in this number, I can clearly see in my tenths column, I've got 2/10, and in my hundredths column, I've got 4 hundredths. So I can partition it like this. So have a look at our second number. We've got 0.75. So you can pause the video and have a go independently. How do you think we could partition this number? Okay then. So we have 0.75 and we can partition that as being 7/10 and 5/100. We could also show this as decimal, so we could have 0.7 because this shows 7/10, and we could have 0.05 because this shows 5/100, because the digit 5 is in the hundredths column. So for silver then, you are completing the part-whole models. Finally then, we have gold. So we have some reasoning and problem solving questions. Max is using a place value chart and 4 counters to make different numbers. Max says if I use all the counters, the smallest number I can make is 0.4. Is he correct? Explain why or why not. So Max has 4 counters and he wants to find the smallest number he can make. So we know that we've been dealing with ones, we've been dealing with our decimal point, our tenths and our hundredths. Okay, so if we popped all of our counters in our tenths column, we are showing what Max has done. So he has shown 0.4 and he thinks that's the smallest number he could make. Well, let's think about our place value. Which column is our smallest, has the smallest value? So where could we place those counters where they would be the least amount they could be? So hopefully you've realised that the hundredths is the smallest column. So if we move these numbers, these counters to the hundredths column, this is the smallest number that Max can make using these columns. So the actual answer would be 0.04. So Max is incorrect because the smallest number he could create with 4 counters is 0.04. Okay then. Another question type, use all the digit cards and the place value chart. Make 3 different numbers. So have a little go at this section here, this first part. You're making 3 different numbers using just these 3 digits. But then it says what is the biggest number you can make. So we will discuss that one together. Pause the video and have a go now. Okay, so there's lots of answers to this. You could have had 1.83, 1.38, 8.31, 8.13, 3.18, 3.81. The list goes on, okay? So, what is the biggest number you can make? If you have a look at our digit card, we want our biggest number to go into our ones column, our biggest number in our column which has the biggest value, okay? So our biggest digit is 8. So if we popped our 8 into our ones column and we cross it off because we've used that one, okay, what's our next biggest digit? It is 3. So our 3 should be in our tenths column, which leaves our 1 for our hundredths column. Okay, so let's check. We know that our ones has the biggest value as the column because ones are 10 times bigger than tenths, which are 10 times bigger than hundredths. So we know we want our biggest digit in our ones to create the biggest number overall. So we've got 8.31, and that is the biggest number we can make. So your goal questions are on the website and they are also here for you to have a look at. And then when you finish those, you have platinum questions to be getting on with independently, which again are on the website.